You may have often wondered where exactly is coordinate geometry used in real life, and if it is not used in real life, why are we even studying it? This video not only tells you about the uses of coordinate geometry in the real world, but also dwells upon solving a couple of problems that we may face in the real life. So let's get into the video straight away. Come on, let's go. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another of our videos. And if you haven't subscribed to the channel as yet, do subscribe to it right now and do not forget to click on the bell notification too. In our previous videos, we have learned how to find the distance between 2 points, how to divide a line segment into a certain ratio, and how to find the midpoint of 2 points. And if by any chance you have happened to miss those videos, then the link to those videos is in the top right corner of the screen. Click on that link and you'll be taken to the video straight away. But all those videos were just theory. We were working on the graph papers, we had the coordinates, and we were finding the coordinate of the midpoint or of a point which divides in a certain ratio. But where is coordinate geometry used in the real life? Well, you have seen a photocopying machine, you have seen a computer scanner, you have seen a camera. How do they store images? Well, it all works on the principle of coordinate geometry because that whole scanner or the whole photocopying machine is divided into small pixels, and the computer and the scanner then takes a picture of the document and stores it in its memory that which pixel is what color, and when it reproduces it, it fills that pixel with that color, and that's how we get a scanned document. That's how we get a photocopied document. That's how we see images on our computers, because even the computer stores it this way, that which pixel is what color. Well, okay, it might work for photocopiers, scanners, computer screens, cameras, but what about other things? Where is coordinate geometry used in real life? Well, if you look at the position of aircraft, they work on the principle of coordinate geometry. If you look at the radio cabs around you, they work on the principle of coordinate geometry. If you see our globe or the map of the earth, they have longitudes and latitudes, which are like coordinates of the earth. So the location of cities are based on coordinate geometry. Architects use it, interior designers use it, and almost everyone uses it. And in this video, we are going to cover a couple of examples where coordinate geometry is used in real life. Well, so this is a question that we have, that John is a computer programmer and he is designing a video game in which he wants a circle of radius 150 pixels in the exact center of the screen. The resolution in which he's making the game is 800 by 600 pixels. Can you help him with the coordinates where he should place the center of the circle? Well, so how do we approach this problem? Well, the first step is that we make a computer screen. So let us say that this is a computer screen that we have, such that the pixel size, this is 800 pixels and this is 600 pixels, and he is looking for the exact center. Now the center may be somewhere here, but we don't know where the center is. But hey, come on, this is a rectangle. Well, you are good at maths, and that's why John needs your help with it. And you know that his computer screen is a rectangle, and you also know that if you draw the diagonals of the rectangle somewhat like this, then the point at where they intersect, they divide each other into equal parts. So both the diagonals of the rectangle are equal, and they divide all these four line segments that we have. They are all equal in size. So the point at which they intersect is the coordinate that you need to find out. Well, so it is clear from this that what we need to find out really is the midpoint of the diagonals. For example, if we have a diagonal, then what we really need is a midpoint over here such that it divides this and this into equal ratios. Well, but how do we find that out? Well, obviously we are going to use the midpoint formula for that, and you remember the midpoint formula. You know that the x coordinates of the midpoint formula should be x1 plus x2 over 2, and y coordinate should be y1 plus y2 over 2. And for that we need the coordinates of this point here and this point here. So well, if it starts from 0 0, if this is the origin and the coordinates are 0 0, then obviously it goes 800 pixels on the right and 600 pixels up. So the coordinates of this point would be 800 600. So this is your x1, your y1, x2 and y2, and this is the point for which you need the coordinates x comma y. X1 is 0, x2 is 800 over 2, that should be the x coordinates of the point, and y coordinate should be y1 is 0 plus y2 is 600 over 2. So that gives us 800 over 2, which is 400, and y coordinate is 600 over 2, which is 300. So the x coordinate is 400, y coordinate is 300. So the ordered pair that we get is 400 comma 300. Now let's have a look on the Cartesian plane and let's see whether the circle looks okay or not. Well, so this is a Cartesian plane that I have, and first of all what we need to draw is the computer screen that John is working with. So to do that, we start from here, 0 0, and we go 800 units on the right, 600 units up, then back to the y-axis and to the origin. So this is the computer screen that John has, and we worked out the coordinates that we needed, which are 400, 300. Well, so 400 on the x-axis is here and 300 units up is here. So we need a point here, which is the midpoint, and this is where he should place the center of the circle. And the question says that he needs a circle of radius 150 pixels. So if he starts from here and makes a circle of 150 pixels, it would be somewhat like this. Well, so that's the circle that we have, and if we want to make it a little colorful for John, what we'll do is we'll just change the color. We'll fill it up with green, and if you look at it closely, it does look like the exact center of the screen, and I'm sure John will be happy with this. Well, that's it. We have found the midpoint already. And if you're happy with the video so far, all you have to do is to show me your love by commenting on the video. Just head into the comment section below and write in the comment, I am loving it. That's it. Just these 4 words. Just write in the comment section, I am loving it. And then right away, let's move to the next example that we have. Well, this is another real life example that we have, that I was once traveling and I wanted to plan my next holiday during this trip. And I wanted to make a trip from Houston to New York, and I don't know the distance between the two places. Unfortunately, due to poor signal on the trip, my data wasn't working, and you know it very well that if the data isn't working, I was not able to access Google on my phone at that time, and I didn't know what the distance between Houston and New York was. But fortunately, I did have an offline map of the USA, and I also have an app in which I have the Cartesian plane. Can I work out the distance myself? Well, let's see what we can do. Well, this is the Cartesian plane that I have, and I want to place the map of the USA on this. And if I want to do that, let's do that and then figure out what to do. Well, so that is the map of USA that I have, and the first thing that we have to do is to adjust the scale. Now I can see the scale at the bottom here. It says this much is 200 kilometers. So I'll have to readjust the map in such a way that it coincides with 1 unit of the box. Well, so probably I'll change the transparency of this. So just give me a minute. I'll try and figure this out. Okay, I've made the map a little lighter so that I can see the coordinates in between. And now I zoom the map so that we can adjust the scale. Well, so there we have it. We have adjusted the scale now such that now this one box is equal to 200 kilometers. Now we bring back what we want to find out. So we want to see New York and we want to see Houston. Now, one of the points I need to mark on the coordinates, I need to keep it at a perfect place so that it makes our calculation easier. So how about placing New York on the coordinates? This. Is Houston still visible? Yes, it is visible. And now let's mark the points that we have. So New York is right here and Houston is here. Now I don't need the picture, so I can remove the picture. Well, so now we have it. We have the 2 points. So this we know is New York and this we know is Houston. The coordinates of New York are obviously on the x-axis 50 and on the y-axis 30. So 50, 30. And the coordinates of Houston will be a little difficult to figure out because they are not on the perfect place. But as I see it, it is negative 42 on the x-axis and negative 27? Negative 42 on the x-axis, and I think this is close to negative 27 on the y-axis. So the coordinates obviously are negative 42 and negative 27. How about taking these coordinates to our sheet and try and figure out the distance formula there? Well, so we have the coordinates of both New York and Houston here, and we are trying to figure out the distance between these two cities. So all that we have to do is to apply the distance formula. Distance formula, if you remember, is d is equal to the square root of x1 x2 minus x1 whole square plus y2 minus y1 whole square. Now to avoid the negatives, what I'll do is I'll probably take this as x1 and this as y1 and this as x2 and this as y2. So what we ultimately get is the square root of 50, which is x2, minus x1, which is 42. So 50 minus negative 42 becomes a positive. So 50 plus 42 whole square plus y2, which is 30, minus negative 27, which becomes positive again. So 30 plus 27 whole square. That gives me the square root of 92 square plus 57 square. So 92 square works out to 8464 and 57 square works out to 3249, which is the square root of 11,713, which equals to 108.22. Now the distance between New York and Houston works out to 108.22 units. And the scale that we saw was one box was equal to 200 kilometers. One box was equal to 10 units there. So 10 units is equal to 200 kilometers. So that means 1 unit will be equal to 200 divided by 10, which happens to be 20 kilometers. So the total distance between New York and Houston would be 108.22 multiplied by 20, which happens to be roughly 2165 kilometers. And this is the last question that we have for the day. Sam has a garden of dimensions 30 meters by 20 meters. He wants to design a flower bed in between the garden such that the distance of the flower bed from one corner is exactly one half of the distance from the opposite corner. Find the coordinates of the flower bed and verify using the distance formula. Okay, so if we understand the problem first, the first part is to make a diagram to understand whether we have really understood the problem or not. So Sam has a garden. Let's say that he has a garden like this. Let's say the dimensions of the garden as given is 30 meters by 20 meters. So this is 30 and this is 20. And he wants to design a flower bed from one corner, which is exactly one half of the distance from the opposite corner. Which means if he has a diagonal like this, and he wants the flower bed at one point in this diagonal such that it is one half from this corner than it is from the other corner. So let's say this is the point that he has, and since it is exactly one half the other, that means the ratio in which this is divided is this is 1 and this is 2. Let me name the garden also A, B, C, D, and let me call this point F, flower bed. Now we need to divide this line segment, find the coordinates of this. We don't know what the coordinates of each of the given parts is, so we will have to assume. So let's take B as 0, 0. So we write, let us assume that the coordinates of B are 0, 0. Then obviously the coordinates of C would be, since this is 30 meters away, so it will be 30, 0, because 30 on the x-axis and it hasn't risen above. And the coordinates of A would then be 0, 20, because on the x-axis it's again 0, while on the y-axis it has gone up 20 units. And we can write that therefore A is equal to 0, 20 and C is equal to 30, 0. Now we'll take this as x1, y1, x2, y2, and we need to find the section formula such that it divides AC in the ratio 1:2. And since we want to find the coordinates of point F, which let us say is x, y, then we need the section formula for that. So let us start with the section formula for that. So section formula, we know that the x coordinates would be Lx1 plus Kx2 over K plus L, and y coordinates would be Ly1 plus Ky2 over K plus L. Now let us put in the values. So the x coordinates of point F would be L is, we know that this is K and this is L. So L is 2. So 2 times x1, which is 0, plus K, which is 1, times x2, which is 30, over K plus L. So 1 plus 2 is 3. And y coordinate similarly would be Ly1. So L is 2. So 2 times y1 is 20, plus K y2. So K is 1. 1 times y2 is 0, over K plus L, which is 3. So the x coordinates in this case would be 2 times 0 is 0 and 1 times 30 is 30. 0 plus 30 is 30. So 30 upon 3, or we can say that is 10. And y coordinates would be 2 times 20 is 40. 40 plus 0 is 40. 40 upon 3 would be 13.33. So obviously the ordered pair, the point F, we can write it here, is 10, 13.33. Now next part of the question says that verify using the distance formula. That means we have to apply the distance formula now and check whether the distance from point A to F is exactly one half the distance from point F to C or not. First of all, let us find the distance between A and F. So we are looking at the point A now and F. So if this is x1 and y1, let me take this as x2 and y2. So distance formula we know is x2 minus x1 whole square plus y2 minus y1 whole square. So that will give me the square root of x2 is 10 and x1 is 0. So that will be 10 square, plus y2 is 13.33 and y1 is 20. So that will give me 6.67, negative 6.67 square, which will be equal to 100 plus 44.5 approximately. So that is 144.5. The square root of that would be equal to 12.02. So this is 12.02 meters. And then we have to find out the distance between F and C. So again, D would then be the same, square root of x2 minus x1 whole square plus y2 minus y1 whole square, which will be equal to x2 is again 10, x1 is 30, so negative 20, the square of negative 20, plus y2 is 13.33 and y1 is 0, so that is 13.33 square, which will be equal to 400 plus 177.7. So the square root of 400 plus 177 would be 577.7, and the square root of that would be 24.04 meters. So as you see, this is 12.02 meters and this is 24.04 meters, which is exactly twice the distance of this. So which is what we did, that this distance is exactly one half of the distance from the flower bed F to the other corner C. So my dear people, these are the real life examples that we come across in our daily life, in which we do have to apply coordinate geometry. And for the time being, I think we have done enough of coordinate geometry, and I was actually thinking about what to make the next video on. I wasn't sure. I was thinking about circle theorems, but if you have a better suggestion, I would like to hear about it. Do head down to the comment section and leave your comments as to what you want me to make my next video on. And to watch that video on circle theorems and to make sure that you do not miss it, All you have to do is to click on my picture here on the screen so that you get subscribed to my channel. And while you're doing it, do not forget to click on the notification bell. And then what you can do is you can also click on these videos appearing on the screen right now, because they are there for your continued learning and very, very necessary for you. Take care. God bless.